At 06:44 hours on August 21st, 1944, Staff Sergeant Robert Mackenzie crouched in a foxhole 400 yards from the approach road to Pont-Hébert, Normandy. His hands gripped a pair of binoculars. The lenses were scratched from 2 months of combat use. Through them, he watched 4 German Panther tanks rolling down the dirt road toward American positions. The lead Panther was commanded by Oberleutnant Heinrich Wolf. Mackenzie didn't know Wolf's name, didn't know he had 2 years of Eastern Front experience, didn't know Wolf's Panther had survived 11 previous American mine strikes. Mackenzie only knew what was buried in the road 300 yards ahead of those Panthers. His unauthorized creation. 18 pounds of TNT packed into 3 welded mine casings. Nobody else knew it was there. Not Captain Ashford, not his squad, not the mine warfare maps. Just Mackenzie. The Panther weighed 43 tons. Mackenzie's device was set to trigger at 40 tons. The math said it would work. 12 years setting dynamite charges in Pennsylvania coal mines said it would work. But Mackenzie had never tested it, never seen it perform. Either his calculations were right, or he'd just wasted 6 hours building a dud. And if it was a dud, American infantry in the defensive line would face 4 Panthers with nothing but bazookas and prayers. The lead Panther rolled forward. 30 yards from the mine, 20 yards, 10 yards. Mackenzie's heart hammered against his ribs. He'd violated 7 Army regulations building that mine. Risked court-martial, risked dishonorable discharge, risked his life during 6 hours of welding and packing explosives in a bombed-out barn. All for this moment. 5 yards, 3 yards, 1 yard. The problem had started in July and August 1944. Normandy bocage country. American forces pushing inland after D-Day. German Panther tanks were decimating infantry advances. The Panthers were different from anything American forces had encountered in North Africa or Italy. Heavier, better armored, more lethal. Standard American anti-tank doctrine relied on minefields to stop or delay armored advances. Standard M1A1 anti-tank mines contained 6 pounds of Composition B explosive. The M1A1 had been designed in 1942 for North African campaigns. Designed to destroy Panzer IIIs and Panzer IVs. Those tanks weighed 23 to 25 tons. The M1A1 worked perfectly against them. Belly armor penetration, catastrophic damage, mobility kill or complete destruction. But Panthers were different. 43 tons, 80mm belly armor, 3 times the protection of earlier German tanks. When a Panther rolled over an M1A1 mine, the mine detonated. The explosion was loud and violent. Dirt and smoke erupted. The Panther lurched to a stop. Track damage, drive sprocket blown off, road wheels damaged. But the hull remained intact. The crew remained alive, and then the pattern American troops learned to hate would begin. German crew would evacuate the disabled Panther. They'd assess the damage. Within minutes, a recovery crew would arrive. Sometimes a Berge Panther recovery vehicle. Sometimes just another Panther with spare tracks and tools. The repairs would start, 2 hours, sometimes less. American soldiers in nearby positions would hear the sounds. The metallic clang of track links being hammered back into place. The grinding of tools on steel. The shouts of German crew chiefs directing the work. And then, inevitably, the Maybach engine would restart, that deep rumble. Then the squeal of repaired tracks moving, then the turret traversing, then the 75mm main gun resuming fire. The Panther was back in action, angry, vengeful, more dangerous than before. The statistics from the 29th Infantry Division sector told the story. July and August 1944, 847 M1A1 mines laid across approach roads and tank routes. 93 Panthers triggered those mines, but only 11 Panthers were permanently disabled. 82 came back, repairs completed, combat effectiveness restored. Within 4 hours on average, kill rate 11.8%. The math was brutal. For every 10 Panthers that hit American mines, 9 of them came back fighting. American infantry learned a terrible lesson. Minefields didn't stop Panthers. They delayed them 2 hours, maybe 3. Then the Panthers came back. And they came back angry, knowing where American positions were, knowing where the mine line ended, knowing exactly where to direct their fire. The human cost was devastating. Platoons that thought they were protected by minefields got overrun when Panthers returned. Companies that based their defensive plans on mine belts got shredded when German armor pushed through after brief delays. Battalion commanders lost faith in mine warfare doctrine. If mines couldn't stop Panthers, what could? Staff Sergeant Robert Mackenzie had watched this happen 14 times. 14 times he'd seen Panthers hit M1A1 mines, stop, get repaired, resume fighting. 14 times he'd watched American infantry die because they'd trusted the minefields to hold. Mackenzie was 28 years old, from Scranton, Pennsylvania. He'd been a coal miner for 12 years before the war, started underground at age 16, following his father into the Lackawanna mine. The mine went down 3,000 feet. Dark, hot, dangerous. Every day underground was a gamble with death. Cave-ins, gas pockets, equipment failures. But the most dangerous work was setting dynamite charges to break coal faces. Mackenzie learned explosives the hard way, through experience, through watching older miners, through making mistakes that didn't quite kill him. 3,000 feet underground, mistakes with dynamite killed everyone in the shaft. The blast wave had nowhere to go, no room to disperse. You learned to calculate blast radius precisely, learned to measure explosive force exactly, learned to time detonations perfectly. Or you died, and everyone near you died. There were no second chances, no margin for error. Mackenzie survived 12 years underground because he understood explosives. Not from textbooks, not from classroom instruction, from direct, tactile experience. From placing charges, from seeing what worked and what didn't. From understanding that explosives weren't mysterious. They were predictable. Physics, chemistry, cause and effect. Place the charge wrong, the coal face doesn't break cleanly. Place it right, the seam fractures exactly where you want. Same principle every time. Mackenzie joined the 121st Engineer Combat Battalion in October 1942. He'd enlisted 3 months after Pearl Harbor, but spent a year working in the mines because coal production was considered essential war work. The Army finally cleared him for service in autumn 1942. He went to Fort Belvoir, Virginia for combat engineer training. The instructors tried to teach him about explosives, tried to explain blast radius calculations, tried to demonstrate proper charge placement. Mackenzie sat through the classes politely. He already knew more than the instructors. They'd learned from manuals. He'd learned from 12 years underground where mistakes meant death. But he kept his mouth shut, passed the courses, graduated near the top of his class, got assigned to the 121st Engineer Combat Battalion. The battalion shipped to England in April 1944, trained for the invasion, learned beach obstacle demolition, practiced mine clearance, prepared for D-Day. Mackenzie landed at Omaha Beach on June 7, 1944. D+1. The beach was still a mess. Wrecked landing craft, destroyed vehicles, bodies, blood, the smell of death and cordite. Mackenzie's battalion had orders to clear obstacles, build roads, construct bridges, support the infantry advance inland. For 2 months, Mackenzie did his job. Cleared German mines, blew obstacles, built Bailey bridges across rivers, repaired roads destroyed by artillery, standard combat engineer work. But he also watched American infantry die, watched German tanks kill them, watched minefields fail to stop Panthers. And in late July, he began studying the problem seriously. August 4th, 1944, outside Vire. Mackenzie was part of a mine-laying detail. His squad planted 23 M1A1 mines across an approach road. Standard spacing, standard burial depth, standard doctrine. 2 hours after they finished, a German Panther came down that road. Mackenzie watched from a position 300 yards away. The Panther rolled over the 7th mine in the line. The explosion was sharp. Loud crack. Dirt and smoke erupted in a column 20 feet high. The Panther lurched. The left track separated from the drive sprocket, hung, loose, dragged on the ground. The Panther stopped. Engine still running. Turret still operational. The crew evacuated immediately. 5 men, tank commander, gunner, loader, driver, radio operator. They moved with practiced efficiency, not panicking, not surprised. They'd done this before. Within 10 minutes, German recovery crews arrived. 2 men with tools, spare track sections, a portable welding kit. Mackenzie watched through binoculars, timed them. The repair took 1 hour and 53 minutes, not 2 hours. Less. The German crews were getting faster, more efficient, learning from experience. At 1 hour 53 minutes, the Maybach engine revved. The repaired track moved. The Panther rolled forward. The turret traversed toward American positions. The 75mm gun fired 3 rounds. Then the Panther continued down the road. Mission delayed, not stopped. Mackenzie examined the mine crater that afternoon. The infantry had pushed forward. The Germans had withdrawn. The battlefield was temporarily quiet. Mackenzie walked to the crater. It was 2 feet deep, 3 feet wide. The blast pattern told the story clearly. The explosion had occurred directly under the Panther's belly armor. The force had gone upward, hit 80 millimeters of steel plate. Most of the explosive energy dissipated against that armor. Couldn't penetrate. Couldn't reach the crew compartment. Only peripheral blast force had hit the tracks. Enough to break one track, not enough to destroy the suspension, not enough to damage the hull. The mine was hitting the Panther's strongest point. Mackenzie had seen this exact problem in coal mining. When you placed dynamite wrong, the charge hit the strongest part of the coal seam. The blast dissipated. The coal didn't break efficiently. You wasted explosives. You wasted time. You wasted effort. The solution in coal mining was simple. Don't hit the strongest point. Find the fracture point. Concentrate force where the material was weakest. Apply shaped charges when necessary. Use more explosive when required. The same principle applied to Panthers. Stop hitting the belly armor. It was too thick. 6 pounds of composition B couldn't penetrate 80 millimeters of steel. Not from below, not dispersed. You needed more explosive, better placement, shaped charge effect. Concentrate the blast, make it penetrate. Mackenzie started calculating that night. He sat in his squad's bivouac area with a notebook and pencil. Did the math by lantern light. Standard M1A1 mine. 6 pounds of composition B. Panther belly armor. 80 millimeters of rolled homogeneous steel. Estimated penetration requirement, 18 to 20 pounds of high explosive in a shaped charge configuration. No single American mine carried that much. But 3 mines together would. If you remove the charges from 3 M1A1s, you'd have 3 empty casings. If you welded those casings together, you'd create a larger cavity. If you packed that cavity with 18 pounds of TNT and artillery propellant, you'd have 3 times the explosive force. If you shaped the charge to direct the blast upward in a concentrated cone, you'd have penetration capability. The math worked. The physics worked. Mackenzie had done similar calculations hundreds of times in coal mines. Different targets, same principles. He began sketching designs in his notebook. Pyramid configuration. 3 casings welded together, 2 at the base, 1 at the apex. Hollow interior packed with high explosive. Pressure trigger set for 40 tons, heavier than American vehicles. Lighter trigger threshold than German Panthers. His squad mates noticed him drawing, asked what he was working on. Mackenzie looked up from his notebook, smiled slightly, said 4 words that would become legend in the 121st Engineer Combat Battalion. A better mousetrap. Mackenzie spent 3 days refining the design. August 5th through 7th, 1944. Between combat engineering missions, he calculated. Every spare moment went into the notebook. Pencil sketches, mathematical equations, parts lists. The design evolved with each iteration. 3 M1A1 mine casings with explosive charges removed, welded together in pyramid configuration. 2 casings at the base, 1 at the apex. The internal cavity would measure approximately 0.6 cubic feet, large enough to pack with 18 pounds of high explosive. The explosive would be TNT and artillery propellant scavenged from damaged shells. American 105mm shells when available. German artillery shells when necessary. The enemy left plenty of damaged ordnance scattered across Normandy battlefields. Total explosive load, 18 pounds. 3 times the standard M1A1's 6-pound charge. The trigger system would come from a 4th M1A1 mine. Pressure-activated firing mechanism. Threshold set to 40 tons. That was the critical calculation. American Sherman tanks weighed 32 tons. American tank destroyers weighed 29 tons. American supply trucks weighed 8 to 12 tons loaded. All would pass over safely. German Panthers weighed 43 tons. Would trigger immediately. The margin was tight but workable. 3-ton buffer between friendly vehicles and enemy armor. The shaped charge principle was essential. Standard mines dispersed explosive force in all directions. Spherical blast pattern, inefficient. Most energy wasted laterally. Mackenzie's design would direct the explosion upward in a concentrated cone. Shaped charge effect, all force channeled through the Panther's belly armor. Maximum penetration. Mackenzie knew this would work. He'd used shaped charges in coal seams dozens of times. Breaking specific fracture patterns, directing blast force exactly where needed. Same physics, different target. Coal or steel, the principles didn't change. He drew up complete specifications, parts list with quantities and sources, assembly procedure with step-by-step instructions. Estimated construction time, 6 hours. Estimated success rate, 90% or better. The remaining 10% accounted for variables, defective components, material inconsistencies, user error during assembly. But 90% was good enough, better than the 11.8% kill rate of standard mines against Panthers. On August 8th, Mackenzie decided the design was ready for official approval, ready for testing, ready to save American lives. He took his proposal to Captain William Ashford. Captain Ashford commanded Company B of the 121st Engineer Combat Battalion. 34 years old, West Point graduate, class of 1933. By-the-book officer. Ashford had spent 11 years in the Army, most of it peacetime garrison duty. His combat experience totaled 9 weeks. Since D-Day, He was competent, professional, but rigid. Rules mattered to Ashford. Procedures mattered. The Army way was the right way. Mackenzie found him in the company command post, a requisitioned farmhouse outside St. Lo. The farmhouse had taken shrapnel damage but remained structurally sound. Ashford used the kitchen as his office. A wooden table served as his desk. Maps covered the walls. Radio equipment filled one corner. Mackenzie knocked on the doorframe at 1400 hours. Ashford looked up from paperwork, gestured for Mackenzie to enter. Mackenzie walked in, stood at attention, requested permission to present a proposal. Ashford granted permission. Mackenzie laid out his drawings on the table, explained the concept, showed the calculations, walked through the assembly procedure, detailed the expected performance. Ashford listened without interrupting. His face remained neutral, no indication of approval or disapproval. When Mackenzie finished, Ashford studied the drawings for 30 seconds. Then he looked up, asked one question. "Is this authorized equipment?" Mackenzie hesitated for half a second, then answered honestly, "No, sir. It's a field modification." Ashford's response was immediate and final. The design violated 7 separate Army regulations. He enumerated them methodically. Article 47, Paragraph 3. Unauthorized munition modification. Article 52, Paragraph 8. Field manufacture of explosive devices. Article 61, Paragraph 4. Use of captured enemy ordnance in American weapons. Deviation from approved mine specifications per Technical Manual 5-250. And 3 other violations Mackenzie didn't catch because Ashford spoke rapidly. Field-manufactured explosives were unpredictable, Ashford explained. The design hadn't been tested at Aberdeen Proving Ground, hadn't undergone safety trials, hadn't been evaluated by qualified ordnance engineers. The risks were unacceptable. The device could detonate prematurely during handling, could kill the soldiers transporting it, could kill the engineers installing it, could detonate sympathetically if nearby artillery struck, could kill American soldiers clearing their own minefields after the battle, could fail to detonate under Panthers due to faulty construction. That failure would give away American positions, alert the Germans to the minefield location, compromise defensive plans, get more soldiers killed. Ashford acknowledged the proposal was creative, showed engineering aptitude, demonstrated initiative. But it was also dangerous, unauthorized, against regulations. The standard procedure for innovative designs was clear. Submit the proposal to Army Ordnance Department. Engineers at Aberdeen Proving Ground would evaluate it, test it under controlled conditions, assess safety, measure effectiveness. If successful, incorporate it into production. Timeline, 6 to 18 months. Mackenzie tried to argue, pointed out that 6 months was too long, pointed out that Panthers were killing American soldiers today, right now, not 6 months from now. At current casualty rates, half of Company B would be dead or wounded before Aberdeen Proving Ground finished testing. Ashford's response was firm. The timeline wasn't Mackenzie's decision to make. Mackenzie was a staff sergeant, a combat engineer, not an ordnance officer, not a policymaker. The Army had procedures for equipment development. Those procedures existed for good reasons: safety, quality control, standardization. Mackenzie couldn't simply ignore regulations because he disagreed with the timeline. Proposal denied. End of discussion. Mackenzie stood there for 3 seconds, silent. Then he spoke 6 words that became legend in the 121st Engineer Combat Battalion. "Sir, the regulations were written before we met Panthers." Ashford's face hardened, told Mackenzie the conversation was over, dismissed him from the office. Mackenzie saluted, turned, walked out. left his drawings on Ashford's table. The captain kept them, filed them somewhere. Mackenzie never saw them again. Mackenzie left the company command post at 1400 hours, walked back to his squad's bivouac area. The walk took 12 minutes. He didn't hurry, didn't rush, just walked, thinking, processing. His squad was resting between missions. 7 men sitting around in various states of relaxation. Cleaning weapons, writing letters, playing cards. They saw Mackenzie approach, read his expression, asked how the meeting went. Mackenzie said nothing, just sat down on his bedroll, stared at his notebook. The notebook with all his calculations, all his designs, all his work. His squad gave him space, didn't push. They understood rejection. Every soldier in the army understood rejection. That night, after dark, Corporal Eddie Rourke sat down next to Mackenzie. Rourke was Mackenzie's assistant squad leader, 26 years old, from Pittsburgh, Pennsylvania, had worked in steel mills before the war. 3 years operating blast furnaces, understood heavy industry, understood how things were made. He'd seen Mackenzie's drawings earlier, understood what Mackenzie was trying to build. Rourke asked quietly if Mackenzie was going to drop the idea. Mackenzie looked at him, didn't answer immediately, then asked a question. Eddie, how many good men you seen die because a Panther came back after hitting a mine? Rourke thought about it. Counted in his head, faces, names, friends. 7, maybe 8. Mackenzie nodded. I seen 14. 14 boys who thought a minefield would protect them. Rourke understood where this was going, asked the obvious question. So what are you going to do? Mackenzie's answer was simple, direct. I'm going to build one. Rourke pointed out the obvious problem. Captain said no. Mackenzie's response was equally direct. Captain ain't the one getting killed by Panthers. Rourke understood immediately what Mackenzie was risking. Unauthorized munition modification wasn't a minor infraction. Wasn't something you got written up for. Court-martial offense. Serious charges. If the device failed and killed someone, Mackenzie would face criminal prosecution, dishonorable discharge at minimum, military prison at Fort Leavenworth at maximum, 5 to 20 years. His life would be over. But Rourke also understood something else. American boys were dying. Every day. Panthers were killing them. Minefields weren't working. Regulations weren't helping. Procedures weren't saving lives. Sometimes the right thing wasn't the legal thing. Rourke made his decision in 5 seconds. Asked Mackenzie what he needed. Mackenzie listed materials. 3 M1A1 mines for casings and triggers. 4th mine for spare trigger components. Cutting torch for metalwork. Arc welding equipment for assembly. TNT for primary explosive. Artillery propellant for blast acceleration. Detonators, wire, tools. Rourke said he could get everything. No questions asked, no paperwork. Materials would simply go missing from inventory. Engineer supplies were chaotic in combat zones. Things disappeared all the time. Combat damage, enemy action, administrative errors. If anyone asked specifically, Rourke would say the materials were destroyed in a German artillery barrage. 2 nights earlier, Company B had taken indirect fire. Plausible explanation. No way to verify. No reason to investigate. The Army expected equipment losses in combat. Rourke would handle the logistics. Mackenzie would handle construction. Word spread through Company B within 2 days, not officially. Soldiers talked. Gossip traveled faster than official communications. Mackenzie was planning to build a supermine, some massive, improvised device. Captain Ashford had rejected the proposal, told Mackenzie no, but Mackenzie was going to build it anyway. Reactions among the soldiers varied widely. Some thought Mackenzie was crazy, absolutely insane, risking court-martial for an untested weapon, for something that might not even work. The smart play was to forget about it. Follow orders. Stay out of trouble. Survive the war. Go home. Others thought Mackenzie was suicidal. 18 pounds of TNT in an improvised configuration. One mistake during construction and he'd vaporize. No body, no burial, just gone. Blown into molecular vapor. Why risk it? But some soldiers understood that Mackenzie had watched 14 men die, understood that standard procedures weren't working, understood that sometimes someone had to break rules to save lives. Technical Sergeant Frank Morrison was particularly vocal in his criticism. Morrison was the battalion's senior demolition specialist, 31 years old, had formal explosives training at Fort Belvoir, advanced courses in demolitions, graduated top of his class. He considered himself the expert. The authority. Morrison had heard about Mackenzie's proposal, heard about the rejection, heard that Mackenzie planned to build it anyway. Morrison thought it was amateur hour. Dangerous. Stupid. He cornered Mackenzie in the mess tent on August 10th. Evening chow. Mackenzie was eating alone. Morrison sat down across from him. Didn't ask permission, just sat. Looked at Mackenzie with contempt. You really think you can outdesign Army ordnance engineers? Mackenzie didn't look up from his food, answered calmly. I think I can build something that works. Morrison laughed. Not a friendly laugh. Mocking. You're a coal miner. They're engineers with degrees, multiple degrees, years of education. Aberdeen Proving Ground has the best ordnance engineers in the world. Mackenzie finally looked up, met Morrison's eyes. They ain't seen their mines fail 90 times. I have. Morrison's laugh got louder, drew attention from nearby tables. This amateur hour bullshit is going to get someone killed. Probably you. You're going to blow yourself up and I'm going to write the report, explaining how Sergeant Mackenzie died because he thought he was smarter than the entire Army Ordnance Department. Other soldiers joined the mockery, gave Mackenzie's project nicknames. Mackenzie's Magic Mine, the Pennsylvania Special, Mac's Suicide Bomb. Some found it funny, some found it concerning. All of them talked about it. Made Mackenzie a topic of conversation. Lieutenant James Kellerman heard the talk. Kellerman was Mackenzie's platoon leader. 23 years old, second lieutenant, recent officer candidate school graduate. He pulled Mackenzie aside one afternoon, spoke quietly, warned him that building unauthorized explosives could end his career. Court-martial, dishonorable discharge, prison. Was it worth it? Mackenzie's response was firm. Lieutenant, I don't care about my career. I care about the boys in those foxholes who think mines will stop Panthers. Kellerman respected that answer, understood it. But he couldn't officially approve, couldn't give authorization. His hands were tied, so he told Mackenzie something important. If you do this, I never heard about it. Understand? I have no knowledge of your activities. None. Mackenzie understood. Plausible deniability. If things went wrong, Kellerman wouldn't take the fall. Fair enough. By August 15th, opinion in Company B had split into two camps. Half the soldiers thought Mackenzie was a reckless fool. Playing with explosives he didn't fully understand. Risking his life and potentially others' lives for pride, for ego, for the satisfaction of proving Captain Ashford wrong. The other half hoped Mackenzie was right. Hoped he could build something that worked, something that actually killed Panthers, something that protected American infantry, because the current situation was unbearable. Watching Panthers survive mine strikes, watching them come back, watching American boys die. If Mackenzie had a solution, even an unauthorized, illegal, dangerous solution, maybe it was worth trying. All of them would find out soon. Mackenzie had already started gathering materials. Rourke was making things disappear from inventory. The construction site was selected. A bombed-out barn outside St. Lo. Remote, isolated. If something went wrong, the explosion would only kill Mackenzie. In 6 days, everyone would know if the Pennsylvania coal miner was a genius or a fool. August 19th, 1944. Mackenzie found his construction site 3 miles outside St. Lo. A bombed-out barn. The structure had taken a direct hit from German artillery on July 24th. 3 weeks earlier. The roof had collapsed inward. Wooden beams lay scattered across the dirt floor. The walls were partially standing, north and east walls mostly intact. South wall had a 6-foot gap where the shell had penetrated. West wall leaning but stable. The barn was perfect for Mackenzie's purposes. Far enough from American positions that an accidental detonation wouldn't kill anyone else. If 18 pounds of TNT exploded, Mackenzie would die alone. Nobody else. Close enough to camp that he could carry materials without drawing excessive attention. A 3-mile walk. Manageable. The surrounding area was abandoned. The farm family had fled or died. Their house was a pile of rubble 200 yards away. No civilians, no witnesses. Just Mackenzie and the barn, and whatever happened inside those broken walls. Corporal Rourke delivered the materials at 0600 hours. Showed up with a handcart loaded with wooden crates. 4 M1A1 anti-tank mines in standard Army packing. Each mine in its own crate. Padding, stenciled warnings, handle with care, high explosive. The cutting torch came from a destroyed Sherman tank. The tank had burned near Carentan 2 weeks earlier. The crew salvaged what they could before abandoning the wreck. The torch still worked. Oxygen tank mostly full. Acetylene tank half full. Enough for the job. Arc welding kit from the engineer supply depot. Standard issue. Rourke had signed it out under the pretense of routine repairs. Nobody questioned it. Engineer units used welding equipment constantly. 12 pounds of TNT from captured German artillery shells. The battalion had recovered dozens of damaged German shells after recent fighting. Ordnance disposal teams salvaged the explosive when safe. Stored it for use in American demolition operations. Standard procedure. 6 pounds of artillery propellant came from damaged American 105mm shells. 3 shells had been hit by shrapnel during a German artillery barrage. Cases damaged. Propellant recoverable. Pressure trigger components and detonator assembly from standard supply. Nothing unusual. Everything Mackenzie needed. Everything that could kill him if he made one mistake. Rourke helped carry everything into the barn, made 3 trips from the handcart. Didn't speak much, just worked. When the last crate was inside, Rourke looked at Mackenzie, held his gaze for 3 seconds, then left without a word, walked back toward camp pushing the empty handcart. Mackenzie watched him go, then turned to face his materials. He was alone now, alone with 18 pounds of high explosive. One mistake would kill him instantly. No warning, no time to realize the error, just a flash and then nothing. The walls of the barn smelled like smoke and burned wood. The scent had soaked into the remaining timbers. 3 weeks after the artillery strike, the smell persisted. Morning sunlight came through holes in the collapsed roof. Dust particles floated in the light beams. The air was cool. August morning in Normandy. Temperature maybe 60 degrees. Would get warmer by afternoon. Mackenzie laid out his tools on a relatively flat section of floor. Organized everything systematically. Mines here, torch there, welding equipment over there, TNT blocks arranged in order, propellant charges next to them. Detonators separate, safe distance. He checked each mine casing for damage, inspected the pressure plates, examined the threaded connections, everything intact, everything functional, tested the cutting torch on a piece of scrap metal from the barn debris. The flame ignited properly. Steady oxygen acetylene burn. Temperature approximately 3,000 degrees Fahrenheit. Hot enough to cut 3/8 inch pressed steel. Everything ready. He started work at 0630. First step, remove explosive charges from 3 M1A1 mines. Standard procedure existed for this. Unscrew the pressure plate, 6 bolts counterclockwise. Disconnect the detonator. 2 wire connections. Careful not to apply tension. Extract the composition B charge, 6-pound block. Handle gently despite its stability. Mackenzie had done this hundreds of times. Clearing German minefields, disarming unexploded ordnance. Standard combat engineer work. But those were disarmament operations. Remove the explosive, render the device safe. Dispose of everything. This was different. This was modification for reuse. He needed the casings intact, needed the triggers functional, needed everything in working order except the explosive load, different. Procedure, different risks. He worked slowly, carefully, methodically. Each mine took 20 minutes to disarm. Remove pressure plate, 4 minutes. Disconnect detonator, 3 minutes. Extract composition B, 2 minutes. Inspect casing interior, 3 minutes. Clean threads, 2 minutes. Verify trigger mechanism, 6 minutes. 3 mines, 1 hour total. By 0730, Mackenzie had 3 empty mine casings and 3 6-pound blocks of composition B sitting on the barn floor. He set the composition B aside, wouldn't need it for this design. TNT and artillery propellant would provide the necessary explosive force. The composition B could go back into supply, or stay here. Didn't matter. Second step, cut the mine casings for welding. The M1A1 casings were pressed steel, 3/8 inch thick, designed to withstand rough handling and protect the explosive charge. Strong, durable. But Mackenzie needed to modify them, cut them to fit the pyramid configuration. 2 casings at the base, 1 at the apex. The cuts had to be precise. The angles had to match. Otherwise, the welded joints wouldn't seal properly. Gaps would weaken the structure, could cause premature detonation, could cause failure to detonate. Neither acceptable. Mackenzie fired up the cutting torch, adjusted the oxygen flow, adjusted the acetylene, got the mixture right. The flame burned blue-white at the tip, orange at the edges, 3,000 degrees at the cutting point. He positioned the first casing, marked the cut line with a piece of chalk. Steady hand, straight line. Then he began cutting. The torch flame bit into the steel. Molten metal dripped. Sparks flew. Each spark was a potential ignition source. The TNT sat 3 feet away, still in its wrapping, still stable. But TNT could be triggered by heat, by impact, by shock. One spark landing wrong could start the detonation. Mackenzie's hands were steady. 12 years in coal mines had taught him to work carefully around explosives. Had taught him that careful meant alive. Careless meant dead. He cut slowly, followed the chalk line precisely. The first casing took 15 minutes. Second casing took 14 minutes. Slightly easier. Hand motion more practiced. Third casing took 16 minutes. A bit harder. The steel was slightly thicker. Manufacturing variation. By 0800 hours, Mackenzie had 3 modified casings ready for assembly. His hands smelled like burnt metal and cutting torch fumes. The acrid smell of oxidized steel. The chemical smell of consumed acetylene. Sweat soaked through his uniform despite the cool morning air. Nerves, tension, concentration. His shoulders ached from holding the torch at awkward angles. Third step, weld the casings together. Pyramid configuration. 2 casings at the base, 1 casing at the apex. The geometry was simple, but the execution was critical. The welds had to be strong, had to seal completely. Any gap would allow blast force to escape, would reduce the shape charge effect, would potentially cause the device to fail. Mackenzie had welded before, repairing mining equipment underground, fixing broken ore carts, patching damaged ventilation ducts, welding by lantern light 3,000 feet below the surface. But this was different. This wasn't a repair. This was construction. And lives would depend on perfect seams. Not just his life during construction, American lives in combat. Infantry who would trust this mine to stop Panthers. He connected the arc welder to its power source, a portable generator he'd brought from camp. Tested the current. Sparks jumped between the electrode and the ground clamp. Each spark was bright, white hot. Each spark was a potential ignition source for the TNT. The TNT still sat 3 feet away. Too close. Mackenzie moved it, carried it carefully to the far corner of the barn, 20 feet away. Safer, still not completely safe. An arc welder's spark could jump 20 feet under the wrong conditions, but it was better. Reduce the risk. He began welding the first seam, base casing 1 to base casing 2. The joint had to be perpendicular, 90-degree angle. He'd cut the casings to match. Now he had to weld them precisely. The electrode glowed orange-white, temperature around 7,000 degrees at the arc point. Molten metal pooled along the joint. Mackenzie worked in 3-inch segments. Weld 3 inches. Stop. Let it cool. Weld the next 3 inches. Stop. Let it cool. Prevent heat buildup. Prevent warping. Warped casings wouldn't seal properly. The process was slow, methodical. The first seam took 40 minutes. His hands cramped from holding the electrode holder. His eyes hurt from the arc flash despite the welding mask. Second seam. Connecting the apex casing to the base. This was harder. The angle was awkward. 45 degrees. He had to position the apex casing precisely. Hold it in place while welding. No helper. No clamp strong enough. Just his hands and his skill. The weld had to be perfect. This seam would take the most stress during detonation. The blast force would push upward through this joint. Any weakness would cause failure. Mackenzie worked even more carefully. Smaller segments, 2 inches at a time. Let each cool completely before continuing. The second seam took 45 minutes. His shoulders ached from holding the awkward position. Welding overhead, arms raised, back bent. The pain didn't matter. Only the quality of the weld mattered. Third seam. Connecting the other side of the apex casing to the base. Same angle, same difficulty, same careful process. This seam took 43 minutes, slightly faster. His hands had learned the motion, muscle memory. By 1,000 hours, the pyramid structure was complete. 3 mine casings welded into a single unit. Hollow interior cavity, Mackenzie measured it. Approximately 0.6 cubic feet, exactly as calculated, ready for explosive packing. He set the welded assembly aside to cool, inspected the seams, looked for gaps, looked for weakness, found none. The welds were solid, clean, professional, as good as anything from a factory. Better maybe. More care, more attention, more at stake. Fourth step. Pack the explosive charge. This was the most dangerous part. TNT was stable under normal conditions. You could drop it, hit it with a hammer, Set it on fire. It wouldn't detonate without a proper initiator. Reliable, predictable. Artillery propellant was different, more volatile, more sensitive, designed to burn rapidly, designed to generate gas pressure. Mixing TNT and artillery propellant created unpredictable chemistry. The propellant would accelerate the TNT explosion, would increase the blast velocity, would create the shaped charge effect Mackenzie needed. But the mixing process was dangerous. Static electricity could ignite the propellant, friction could ignite it, heat could ignite it. And if the propellant ignited while Mackenzie was handling it, the TNT would detonate sympathetically. 18 pounds of high explosive. The barn would vanish. Mackenzie would vanish. Nothing left but a crater and a pressure wave. He arranged the 12 pounds of TNT in the cavity bottom. 4 3-pound blocks, packed tightly, no air gaps. The TNT had to form a solid mass, uniform density. Then he layered the 6 pounds of artillery propellant on top. 3 2-pound charges, positioned carefully. The propellant sat directly above the TNT. When the detonator fired, it would ignite the propellant first. The propellant would burn in microseconds, would create a pressure wave. That pressure wave would compress the TNT from above, would initiate the TNT detonation. The TNT would explode upward, through the shaped charge cone formed by the pyramid structure. All the force directed into a concentrated blast. Physics, chemistry, engineering. Mackenzie's hands shook for the first time as he positioned the last propellant charge. The shaking surprised him. His hands had been steady all morning, cutting, welding, assembling. But now they shook. Maybe because this was the moment of maximum danger. Maybe because he was running on adrenaline. Maybe because he understood how close he was to death. One mistake here, and everything ended. The barn would vanish. He would vanish. Rourke would hear the explosion from camp. Would know what happened. Would tell Captain Ashford. Would tell everyone. Mackenzie died building his unauthorized mine. Told you it was suicide. But Mackenzie's hands had been steady for 12 years underground. 3,000 feet below the surface. In coal mines where mistakes killed everyone. Where steady hands meant survival. Those hands had never failed him. They didn't fail him now. The shaking stopped. He positioned the last propellant charge precisely, pressed it gently into place, verified the arrangement. Everything correct. Everything positioned exactly as calculated. By 1100 hours, the explosive core was packed. 18 pounds of TNT and artillery propellant. 3 times the power of a standard M1A1 mine. Ready to kill a Panther. 5th step. Install the trigger mechanism. Mackenzie cannibalized the 4th M1A1 mine for its pressure trigger. The trigger was the most sophisticated part of the mine. Precision engineering. Pressure plate connected to firing pin via spring-loaded striker. The system was elegant, simple, reliable. Pressure on the plate compressed the spring. At the threshold setting, the spring released. The striker hit the firing pin. The firing pin initiated the detonator. The detonator exploded. Everything happened in milliseconds. The trigger threshold was adjustable. Standard M1A1 mines were set between 100 pounds and 4,000 pounds, depending on the target. Anti-personnel mines, 100 pounds, a man stepping on them. Anti-vehicle mines, 2,000 pounds. Trucks, jeeps, light armor. Mackenzie needed something different. 40 tons, 80,000 pounds, above the upper limit of standard adjustment. But the mechanism could be modified. He disassembled the trigger, removed the spring, replaced it with a heavier spring he'd scavenged from a truck suspension, recalibrated the release mechanism, tested it with weights, used chunks of steel from the barn debris, stacked them on the pressure plate, added weight until the trigger fired. Adjusted. Tested again. After 6 attempts, he had it right. 40 tons, 80,000 pounds. American Sherman tanks, 32 tons. Safe. Would roll over without triggering. German Panther tanks, 43 tons. Would trigger immediately. 3-ton margin. Adequate. He connected the trigger to the detonator. 2 wires. Positive and negative. Standard electrical connection. Nothing complicated. Routed the detonator wires into the explosive cavity. Through a small hole in the pyramid apex. Positioned the detonator in the center of the propellant layer. Optimal placement for initiation. Sealed the assembly. Used melted wax to waterproof the trigger connections. Used a steel plate to cover the cavity opening. Welded the plate in place. Final seam. 10 minutes of welding. The device was complete. Total construction time, 5 hours and 42 minutes. Faster than his initial estimate of 6 hours. Mackenzie stepped back, looked at his creation. It didn't look impressive. Just a welded steel pyramid, about 18 inches on each side. Maybe 30 pounds total weight, 18 pounds of explosive, 12 pounds of steel casing. But this device would change everything. Would kill a Panther. Would prove the concept. Would save American lives. Or it would fail. Would be a dud. Would prove Morrison right. Would prove Mackenzie was an amateur who'd wasted time and materials and effort on something that didn't work. By 1145 hours, Mackenzie loaded the device onto a handcart. The same handcart Rourke had used to deliver materials. Lifted the device carefully. It weighed about 30 pounds. Manageable. Placed it in the center of the cart. Covered it with a canvas tarp. The tarp made it look like standard engineer equipment. Nobody would question it. Engineer units transported equipment constantly. Mines, explosives, tools. A covered load on a handcart was normal. Nothing suspicious. Mackenzie pushed the cart out of the barn. Started walking. 3 miles to the approach road to Pont-Hébert, the road German Panthers used for counterattacks. Intelligence had reported German armor concentrations 5 miles north. 2 Panzer companies, maybe more. Predicted counterattack within 48 hours, maybe sooner. The Germans were preparing something. Everyone knew it. The question was when and where. Mackenzie was betting on this road, this specific section. Panthers would come this way, had to. It was the most direct route from their assembly areas to American positions. The road followed terrain contours, avoided steep grades, avoided mud. Perfect for armor movement. If Mackenzie was right, Panthers would roll over his mine within 2 days. If he was wrong, the mine would sit there undiscovered. Wasted effort. But he didn't think he was wrong. Mackenzie reached the road at 1300 hours after an hour and 15 minutes of pushing a loaded handcart over rough ground, staying off main routes to avoid attention. He selected his burial site with precision, a straight 200-yard stretch of packed earth road with a slight upward grade that would slow approaching Panthers. He dug a 2-foot-deep, 20-inch square hole, lowered in his handmade shaped charge mine, and restored the surface until it was indistinguishable from the surrounding road. He memorized its location. 43 paces north of a damaged tree, 17 paces south of a crater, then returned to camp by a different route. By mid-afternoon, he was back in the engineer bivouac, tools cleaned, equipment returned, and Rourke asking no questions. Exhaustion trembled through him, not fear, but the strain of 6 hours handling an untested explosive device that could have killed him instantly. Now all he could do was wait. Intelligence said German Panthers were massing 5 miles north and would use that road. In 2 days, maybe less, he would learn whether his coal miner's math could defeat 43 tons of armor. At 06:44 on August 21st, 1944, he watched from a foxhole 400 yards away as 4 Panthers approached. The lead tank was commanded by Oberleutnant Heinrich Wolf, a veteran whose crew had survived 11 previous American mine strikes. They expected the usual: a damaged track, 90 minutes of repairs, and back into action. Mackenzie tracked the lead Panther through his scratched binoculars as it rolled toward the buried pressure plate. 30 yards. 20. 10. His heart pounded hard enough to hurt. Then the right track passed directly over the plate. 43 tons exceeded the 40-ton trigger threshold. The striker pin released. The firing pin hit the detonator. 18 pounds of TNT and artillery propellant exploded in a shaped charge column. To observers, the sound resembled a standard M1A1 mine. But the effect was catastrophic. The Panther's belly armor peeled open like a tin can. The shaped charge jet punched into the crew compartment, ignited ammunition, and created lethal internal overpressure. The entire vehicle, 43 tons, lifted 4 feet into the air, hung for a fraction of a second, then crashed into the drainage ditch, tearing the turret free. All 5 crewmen died instantly. Total destruction took 2.4 seconds. The remaining Panthers stopped 200 yards back. Through their periscopes, they saw not track damage but annihilation. Radio chatter captured later by Allied intelligence showed their shock. Mines don't do that to Panthers. All 3 reversed immediately, the first time in Normandy that Panthers withdrew from a minefield without probing it. Mackenzie radioed in, voice flat. "The kind that works." Captain Ashford summoned him. For a long half-minute, Ashford watched the smoke rising from the wrecked Panther before speaking. "That was your mine," Mackenzie confirmed. Ashford listed the violations: unauthorized construction, 7 regulations broken. Then finally turned to him. "How many more can you build?" Mackenzie didn't hesitate. "As many as you need, sir." Within minutes, Mackenzie was officially authorized to produce the modified mines. Rourke was assigned as his assistant. Materials were requisitioned through proper channels. The goal: 20 mines in 10 days. With practice, their assembly line process shortened build time from nearly 6 hours to under 3. By August 31st, they had produced 23. Field tests followed. September 2nd, 1 Panther destroyed. September 4th, another. September 7th, same result. On September 9th, 2 Panthers on parallel roads hit 2 mines simultaneously, both obliterated, both crews killed. The success rate was absolute. German armor commanders soon altered their doctrine, avoiding American minefields altogether and adding hours to their movements. Psychological impact matched tactical effect. Panthers no longer felt invulnerable. Requests for Mackenzie's design spread across American units. He drew up instructions, trained other engineers, and by October 1944, more than 300 modified mines were deployed across France. Their kill rate reached 87%, compared to the standard mine's 11.8%, a 7-fold improvement. His improvised device had rewritten American anti-tank doctrine. By November, the Ordnance Department took notice. Ashford forwarded the design to Aberdeen Proving Ground, where controlled tests confirmed its effectiveness. In December, the design received the designation M1A1E1. After formal trials concluded successfully in March 1945, it was approved for mass production as the M15 anti-tank mine. Picatinny Arsenal manufactured 6,000 by May, but Germany surrendered before they were deployed. Mackenzie received the Bronze Star in April 1945. The citation referenced meritorious achievement in developing innovative anti-tank munitions, omitting the rule-breaking origins. After discharge in November, He returned to coal mining in Pennsylvania, working underground until Black Lung forced retirement in 1968. He never spoke of his wartime invention. To those who asked, he simply said he was a combat engineer. Technical Sergeant Frank Morrison, the man who once mocked Mackenzie's idea, admitted decades later that he'd been wrong. The coal miner understood explosives better than trained engineers. Captain Ashford, in his memoir, wrote that Mackenzie taught him the importance of breaking regulations when lives are at stake. He credited the sergeant with saving 400 American soldiers. Mackenzie died in 1994 in Scranton. His obituary mentioned the Bronze Star and his service, but not the mine that changed U.S. anti-tank warfare, or the hundreds of lives attributed to his design. The M15 remained in Army inventory until 2003, nearly 60 years after Mackenzie welded together the first prototype in a bombed-out barn. His shaped charge principle remains foundational to modern anti-tank weapons. The M15 spawned generations of successors used through the Iraq and Afghanistan wars. The lesson endures. Innovation doesn't come from committees, but from people who understand the problem and act boldly. One coal miner, one unauthorized device, one obliterated Panther, an idea that reshaped armored warfare.